So here is the first step of the process where Nithya is ultrafiltering some of our river water.
Welcome to Engineered at Tech, where we showcase how engineers at Georgia Tech are working to solve the world's grand challenges. Hi, I'm Harrison Burnside, an undergraduate engineering student here at Tech. On today's episode, we're exploring water quality. We all need clean drinking water to survive, but in many parts of the world, it's hard to come by. Here in Atlanta, we rely on the Chattahoochee River for all our water needs, including recreation. Shooting the hooch during the summer is a favorite Atlanta pastime. And it's not just Atlanta. The Chattahoochee is a crucial resource that millions upstream and downstream depend on. But it's a constant battle to keep this river clean. So let's visit someone who's working to keep water clean, including our very own Chattahoochee River. Environmental Engineering Assistant Professor Katy Graham is working in her lab to engineer new ways to track pathogens in the water. Let's go meet her. I think this is it. Hi, Dr. Graham.
Hey Harrison, welcome to the lab.
Thanks for having us today. Can you tell us where we're standing right now?
Sure, we're in my lab where we look at the fate and transport of pathogens in the environment, places like the built environment, like buildings, also in the natural environment, like the Chattahoochee River.
So how bad is the water quality in the Chattahoochee?
It can be pretty variable. North of the city, the water quality tends to be much better. As we get into urban areas, especially after rainstorms, the water quality deteriorates, and we need to figure out where the sources of those pollution points are.
So how do we measure that pollution?
Sure. Well, we typically use an EPA standardized method and framework to take samples of water from the Chattahoochee, mostly done by local agencies. We then enumerate fecal indicator organisms in those samples and compare them against a health-based standard. That typically can't help you identify the source of the pollutant. So in my lab, we're using and developing a new DNA-based method where we can understand better the specific sources of pollution to the Chattahoochee, for instance.
Can you show us how it works?
Sure. So here is the first step of the process where Nithya is ultrafiltering some of our river water. We take very large volumes of river water. We then concentrate them using this membrane into much smaller volumes, which helps increase our sensitivity. Once we have these samples, we then move to nucleic acid extraction. So here, Jake is using a combination of chemical and mechanical lysis to break open any organisms in our samples. And that way we can purify and use the DNA in those samples to sequence or analyze further. And the next step of the process takes place down the hallway. So let's walk down there now.
Perfect.
So now we're at the last step of the process where Jake takes those extracted samples, adds them to this plate, and puts them into our digital PCR machine. And Jake recently analyzed some samples from the Chattahoochee for 5 different markers of fecal pollution in the river water. First, he looked at a sewage-specific marker and sees that there are certain hotspots in the Chattahoochee that are positive for this marker, showing potentially recent sewage spills. One surprising finding that we saw was that when he looked at the dog fecal marker, that there are other parts of the Chattahoochee that are very positive for this marker, showing that dog inputs can impact public health and water quality in these areas of the Chattahoochee alongside sewage.
That's really cool data. So what kind of impact do you think this work can have, though?
Sure. So our first goal is local. We want to help local agencies guide their resources towards constraining sources of pollution in the river to protect public health ultimately. But our second goal is more broad. We're hoping to develop and validate this method a little bit more so that other researchers, as well as agencies across the United States and the world, can use this to protect their water and protect public health.
Wow, thank you so much for your time today, Dr. Graham. And that's it this time. We've got more interesting work to explore around campus, so we'll see you next time for our next episode of Engineered at Tech.